Sure then. One second, Anna. Let me open whiteboard. Then I will solve. Hmm. Planck quantum theory.
Hello, sir.
Hello.
Yes, sir.
Tell me, Anna.
Okay, sir. 1 minute.
Hello.
Sir.
Students, can you hear me properly?
Yes, sir.
Hmm. So, Planck quantum theory. Actually, what we said actually. So, in order to explain drawbacks of the wave theory, okay. So, Planck quantum theory was dis- okay introduced. So, what is Planck quantum theory says actually? Uh, in wave theory, it was said that the energy which is coming from any source, it will come continuously. For example,
Hello. Email.
now all of you look at, listen, and play it, mute yourself.
Masay.
Vagdevi, please mute yourself now. Okay, so Planck quantum theory. So, so that is actually wave theory main point. But actual Planck quantum theory says that the energy comes from any source. Light, heat energy or okay, light, heat energy or light energy. Take any source.
So that means any form of energy, sir.
Yes, light or heat. Okay, these two particularly. Any source comes in discontinuous manner. Discontinuous manner by discontinuous manner in the form of small discrete
Sir, what is
packets.
discrete?
Okay, that means the energy which is coming from any source, no, it will come in small packets. Okay, these packets only called as a quanta. Okay, these packets only what we can solve. Packets are called quanta. Quanta. And in case of light, light. These small packets are called photon. That means any source it will come in small packets. Okay, in the form of small packets. These packets only we are saying that photons are quanta. So in case of light, as if I'm taking these packets only we are saying that photon we can say. Okay, na? And next point is the energy of quanta is directly proportional to frequency. Okay, so the understood, Anna? That means what we can say simple C. So this is the source, let me take, and here it is target, let me assume. Then what will happen? Source will light will come in the form of like this. So this is one packet, this is one packet, this is one packet, this is one packet, this is one packet. So these small packets only called as photons we can say. Okay, so that's why what we can say, and energy of the photon is there, no? It is directly proportional to frequency of the light. By removing the proportional symbol, obviously we'll use some constant, no? That is equal to h nu, where h is Planck constant. That only, no? Planck constant, and the value is 6.625 into 10 to the power of minus 34 joule second, or 6.625 into 10 to the power of minus 27 arc second.
Sir, and I didn't understand the question that you gave about photoelectric effects, sir.
Huh?
I didn't understand the question that you gave about photoelectric effects, sir.
Now, first you asked me about quantum theory, no?
Yes, sir.
Uh, Planck quantum theory also you said, no?
Yes, sir.
So according to that only I'm going, no?
Yes, sir.
Uh,
Sir, what is Joule second, sir? Why is it Joule second?
joule second units, nana.
Sir, means its dimensions are energy and time, sir.
Frequency, no? H, how we can write energy by frequency, no? Frequency is second inverse, no?
Okay, sir.
Okay, na?
Yes, sir.
Done?
Yes, sir.
So this is about the Planck quantum theory. Next one. So should I take questions on photoelectric effect or concept you need?
Question, sir.
Do you have any particular questions which you haven't got?
Yes, sir.
Can you read?
Yes, sir.
Tell me.
A 100-watt bulb
100-watt bulb
emits monochromatic light
emits monochromatic light,
of wavelength 400 nanometers.
chromatic light of wavelength
400.
light of wavelength 400
Nanometers.
nanometer. Next.
Calculate the number of photons emitted.
Calculate number of photons emitted. Now see, in the above formula only, okay, actually this is not photoelectric effect formula. This is Planck quantum theory problem. Actually, E equal to NH nu we can write. Okay, where N equal to number of photons, right? Because this is the one photon energy, na?
Yes, sir.
Now what is given? A bulb power given. What means energy per second? Okay, what is nothing but what power? Okay, that means what 100 joules per second. Simply we can say. So energy of the bulb equal to 100 watts. That means 100 joules per second. Joules per second, uh, by energy. Okay, 100 joules per second we can take. Okay.
So once will you go to previous slide and question?
Next, what is asking? A monochromatic light having wavelength. That means a photon single quanta wavelength given. Okay. Quanta wavelength given. Quanta wavelength.
What's it?
Wavelength given a quanta. 400 nanometers means convert into centimeters or meters. 1 nanometer equal to how many meters? How many meters? Hello? 10 to the power of minus 9 meters. That means it will be 4 into 10 to the power of minus 7 meters. Therefore, energy of energy of one photon we know, that is equal to E equal to h nu, and we know C equal to nu lambda relation. From this one, what we can write? E equal to hc upon lambda. That is E equal to h value how much? 6.625 into 10 to the power of minus 34. Okay, joule second into velocity of light how much? 3 into 10 to the power of 8 meters per second by lambda
Sir,
value is of
C is light, sir.
uh,
H C by lambda, no, sir.
c means what? Velocity of light, no?
Yes, sir.
Uh, what is the speed of light? 3 into 10 power of 18, no?
Yes, sir.
6.625 into 3, nearly it value will be 19.985 it will get. So let me take it as 20. Okay, into 10 to the power of minus 34 and 10 to the power of minus 8 plus 8. So how much value we will get? So if I'm taking this
Sir, minus.
minus 26, no? That means
Yes,
what
sir.
we can say, that will be 20 into 10 to the power of 37, 34 and 8. Means how much it will be? 26, no?
Yes, sir. Minus 26.
By 4 into 10 to the power of minus 7. So 4 1 ja 4 5 ja. So that means what? 5 into
5 into 10 power
well,
minus 19.
minus
19, sir.
19. So this is your energy of one photon. Now energy given how much? This is joules, no? So total energy of the bulb given how much? 100, no? 100 joules. Okay. Now energy of one photon, therefore what we can write? We can write no total energy equal to n into energy of one photon. So this h nu value already we calculated. That is 100 equal to some n into energy of one photon, that is 5 into 10 to the power of minus 19. So 5 1 ja 520. Therefore n equal to what we can write? 20 by 10 to the power of minus 19, which means 20 into 10 to the power of 90. Is this is the only answer?
Uh, yes, sir. Yes, sir.
Uh, Next. Any other question do you have which you haven't got?
No,
Tell me, no issue for me. Tell me. No objection.
no, sir.
Okay. Mm. So shall I start? Any new topic or any questions?
New
Mm.
sir, new topic, sir.
Okay. Mm. టాపిక్ వచ్చేసరికి ఇది సింపుల్ టాపిక్ ఓన్లీ. ఓకే. రిడాక్స్ రియాక్షన్స్. So redox means the reaction in which reduction and oxidation. So for that one, first we need to know what is oxidation and what is reduction. First point we need to identify. Okay. Oxidation and reduction. So generally oxidation means what we can say, the reaction in which addition of oxygen takes place. Okay, is called oxidation. So oxidation I will represent with OXD power n. Okay, reduction I will represent with RED power n. I will represent. Similarly, removal of from any process, if you are removing hydrogen also, also called oxidation. Or this one is important for us, that is loss of electrons is called oxidation. Next here, so here what we can say, reduction. So addition of hydrogens is called reduction. Either addition of hydrogen or a removal of oxygen or gain of electrons is called reduction. Okay, so what we can say, either loss of electrons or gain of electrons. Loss of electrons is called oxidation and gain of electrons is called reduction. Okay, so in this topic completely, we are majorly concerned with this. Okay. So before that one, how to calculate oxidation state? Okay, oxidation state.
So once giving me to previous.
Oxidation state. 1 second.
Sir, we learned this chapter in ninth class.
So you studied in ninth standard or
Sir, in ninth standard.
acha, okay.
Yes, sir.
Okay. Okay. Hmm. So oxidation statements, it is like a charge of hello. Can you hear me?
Yes, sir.
Oxidation state is also called as a oxidation number. Also, we can call. Okay. Uh, Oxidation state or oxidation number means
Sir, you wrote oxidation states, sir.
it's a state, no? STAT. Oxidation state, which is also called as oxidation number. Simply, oxidation state or oxidation number means it is like what we can say. Can you hear me?
Yes, sir.
Oxidation state means simply it is like it is it is charge on atom uh, in a compound or in a molecule. In a molecule. Okay, simply this oxidation state can be okay. Oxidation number or oxidation state can be state can be 0 or positive.
Sir, like proton, neutron, and electron only, na sir.
No, that is different completely. Because if I'm taking hydrogen, if I'm taking, so it always have one proton or an electron only. But hydrogen, to which atom it is combined. So depends on that its oxidation state changes. Positive, neutral already kana. Positive, negative, or maybe fractional. Okay, so it can be negative, it can be positive, or it can be fractional as well.
That means somewhat positive and somewhat negative, sir.
Huh?
That means fractional means somewhat negative and somewhat positive, sir.
Yes, 3 by 4 fractions, na? 3 by 4, 2 by 3, likewise. Okay. Okay, students. Next one. For any atom, how to calculate oxidation number? Okay, how we can calculate the oxidation number is very, very important now. Okay, na? Mm. Mm. See. So calculation of oxidation number, how to calculate? So simply, like these are nothing but rules, nana. So first rule is rule number one. Okay, that is the sum of oxidation state of all the atoms in a molecule is 0 in case of neutral molecule, or it is equal to its charge in case of ions. Anyone understood what I have written here?
Yes.
That means while calculating oxidation state or anything, hello, hello.
Yes, sir.
So that means while calculating oxidation state, okay, the sum of all the atoms, okay, is 0 or it will be equal to its charge in case of ions. Let me take an example. KMnO4 I have taken. So here how many atoms are there? That is potassium, manganese, and oxygen we are having, isn't it? And it is neutral molecule or ion?
Neutral.
Neutral molecule. Very good. That is, so as per the rule, what I am saying that oxidation state of potassium plus oxidation state of manganese plus how many oxygen atoms are there here?
4, sir.
4. That means what we can say, plus
4 into
4 into oxidation state of oxygen atom is equal to 0. So from this formula, if we know potassium and manganese, so can we calculate oxidation state of oxygen?
Yes, sir.
Or if we know oxidation state of oxygen and potassium, I can calculate oxidation state of manganese. Can we calculate or not?
Yes, sir.
We can calculate, right?
Yes, sir. So I can take the uh, element as X and then we can do it, sir.
Ah, yes, very good. Okay, now students. Next, one more example if I'm taking. If I'm taking SO4 minus 2. Here how we can say?
Sir, oxidation number of
That means what?
sulfur
Oxidation
oxidation.
state of,
So sulfur plus 4 into oxidation state of oxygen equals to -2.
very good. 4 into oxidation state of oxygen is equal to minus 2. So in the same way, if I'm taking NH4 plus also, you will write like this, no? Okay, if I'm taking positive charge also, you will write like this only or not? Okay. Otherwise, one more example, if I'm taking NH4 plus. So here what we can say, tell me? Nitrogen plus
One, sir.
4 into oxidation state of hydrogen is equal to plus 1. Okay, now students? Mm. Next one, rule number 2. That is oxidation state of oxidation state of alkali metals. What are the alkali metals? Lithium, sodium, potassium, rubidium, and cesium is always plus 1. Okay, see always is always plus 1 only. Okay, na?
Sir,
Hmm.
SO for -2. Oh,
Uh,
okay, sir. Nothing, sir. 4 into I did not.
okay,
Yes.
next, rule 3. This you need to remember these rules, then only you can solve questions. Oxidation state of alkaline earth metals, that is which one? beryllium, magnesium, calcium, strontium, barium is always +2. Okay. Next. Four. Uh, oxidation state of fluorine is -1
Sir,
always.
-1, sir.
Okay. Next row. Oxidation state of hydrogen is
Sir, plus
plus.
1, sir, but in case of metal hydride, it's -1.
uh, but in case of metal hydrides, hydrogen oxidation state is okay. Next. Hmm. What we can say, Nana? Oxidation of hydrogen we have done. First group, second group we have done. Fluorine we have done. Next,
It's oxygen, sir.
one more I will tell you before that. Okay. Uh, generally, the highest oxidation state of atom is equal to its group number. Okay. This is what we can say oxygen state. Okay. And one more is there that we will discuss in next class. Okay. I do have next class. Okay, now students.
Yes,
In next
sir.
class we will meet you. Before that one, just you complete the this topic and come to class by reading.
Okay,
Good
sir. Thank you, sir. Bye, sir. Good night, sir.
Bye, sir. Thank you, sir. Great, sir.